Hello everyone! In this video we will work out several exercises together about reaction rates and equilibria. In this exercise, several graphs are shown, in which the concentration of several species is plotted at different times. The first of these graphs is shown here. The question is as follows. Several graphs are shown in the next few questions. The reaction equation for each of these reactions is A plus 2B becomes C plus 3D. In the graph below, the concentration of several species in an aqueous solution is shown over time. At around which time are these species in equilibrium? Let's zoom in on the graph. Equilibrium is reached when the concentration of each species does not change over time anymore. In the graph, it can be seen that this is already the case from around 10 minutes. This means that equilibrium is reached at around 10 minutes. In the following graph, the concentration of these species is shown again. Which of the following statements is true? Multiple answers can be correct. Let's take a look at the first two answers, A and B. Is the reaction faster or slower than before? In order to draw a conclusion about the speed of the reaction, we need to take a look at the graph, specifically at the 10-minute mark, which we saw in the previous part of the question. What we see here is that equilibrium has not been reached yet at the 10-minute mark. In addition, we can see that the equilibrium concentration of each species has changed compared to before. This will be important for the next part of the question. Because equilibrium is not yet achieved at the 10-minute mark, which was the case in the previous example, we can conclude that the equilibrium is reached slower than before. The second part of the question was about the effect of temperature on the reaction. First, we already know that the reaction is slower than the previous example, so something must have changed. We also saw that the equilibrium concentrations have changed. This means that the temperature must have changed. This is because changing the temperature would change the equilibrium constant, which directly affects the concentrations of each species at equilibrium. Now let's assume that the reaction is exothermic. This means heat is released during the reaction, which, when this is the case, and the temperature at which the reaction takes place is increased, the reaction will be slower. This means that C is the correct answer. There is one more exercise in this set of three. Is the equilibrium reached faster or slower than before in this situation? What happened to the temperature?